N1 and EGT are the primary indications, and they appear on the upper EICAS display. The secondary indications can display on the lower EICAS display. They consist of the N2, fuel flow, oil pressure, oil temperature, oil quantity, and engine vibration.
The controls for the engine indications are on the EICAS control panel, which is located directly below the EICAS CRTs on the forward electronics control panel. The application controls are the engine display switch and the thrust reference set controls.
The upper EICAS always displays the primary engine indications. The engine display switch controls the lower screen. Pressing this switch will either blank or display the secondary engine display on the lower EICAS screen.
Cyan arrows display on the upper EICAS when the lower EICAS is selected. If the lower screen is selected for blanking, these cyan arrows are not displayed. Therefore, if the cyan arrows are displayed, the crew expects the lower screen to not be blank. In this case, if the lower screen is blank, the crew knows it has failed.
The normal operating range of all parameters is indicated in white. Caution ranges are depicted by amber bands. Whenever any parameter reaches the amber band, the pointer, digital readout, and readout box change from white to amber. Please read the note about when the amber EGT color is inhibited for takeoff. If a parameter continues to increase to the red line limit, the pointer, digital readout, and readout box will all change to red. Please read the notes about exceedances. If one CRT screen fails, the two displays will combine in a compacted mode on the operable CRT screen. N1 and EGT remain the same as during normal display, but all other displays change to digital readouts. When the display is compact, if an amber or red line parameter is reached, the digital indication changes color to amber or red as shown here by the right engine N2 display. It is possible that the secondary engine indications are not always in view because the pilot may have blanked the screen or selected the status page. In this situation, if any N2 RPM reaches the red line limit, both engine N2 indications are automatically displayed. Likewise, if the lower screen is blanked when oil pressure or temperature reach the amber band or the red line limit, or when the oil quantity decreases into the low quantity band, all oil parameters for both engines are automatically displayed. The upper EICAS also displays the current thrust rating limit mode, total air temperature, assumed temperature, and thrust reverser indications. Here are some examples of thrust modes that can display on the EICAS. Your crew operating manual has a complete list of available thrust modes. Note: the go-around thrust mode display appears when flaps are extended or when glide slope is captured to also indicate that the AFDS go-around mode is available. On this frame, we show total air temperature of 12 degrees centigrade and 46 degrees centigrade for the selected assumed temperature for reduced takeoff. A display of reverse indicates the thrust reverser mode. Amber, reverser in transit. Green, reverser fully deployed. We will now describe the specific displays and color convention of each engine parameter. The N1 is the primary thrust indication. The white pointer and boxed readout indicate the current N1 RPM. An amber band on the outside of the arc indicates the caution range for the N1 RPM. A red line indicates the N1 RPM operating limit. If the pointer moves into the red line area, both the pointer and the boxed readout will be red. Another amber line, this one inside the arc, displays the maximum available thrust that would be available if the thrust levers were moved full forward. This value is determined by the electronic engine control, or as an alternate, the thrust management computer. Therefore, this amber line indicates the protection that is provided by the EEC, and that if the pilot firewalled the thrust levers, this would be the maximum thrust available. An N1 reference target bug displays to indicate the current reference N1 limit. Similar information is displayed digitally above the N1 gauge. These bugs represent the maximum thrust that may be set by the auto throttles for the current thrust reference mode. The bug value will change according to many factors. Note: the bug is green when it is computed by the thrust management computer and is magenta when it is the FMC commanded target N1 with VNAV mode engaged. The command sector is a white band that momentarily appears to indicate the difference between current N1 and the N1 commanded by throttle position. Therefore, this momentary display appears when rapid thrust lever movements are made to indicate the expected thrust value prior to the engine reaching the selected value. As the engine accelerates or decelerates to match the commanded setting, the command sector is erased. The command thrust level is a white line that displays at the end of the command sector. It indicates the N1 commanded by thrust lever position. It becomes the extension of the N1 pointer when the current N1 and commanded N1 are the same. A white pointer and boxed readout provide the EGT indication in degrees centigrade. The amber band indicates the maximum continuous EGT limit. The red line indicates the maximum takeoff EGT limit. The pointer and readout will normally be amber or red if the EGT reaches the respective limit. Please read the note about the inhibit of amber color during takeoff and go-around. An EGT start limit line displays red whenever the engine is not running. Therefore, this line appears after engine shutdown and remains displayed after start until the engine operation is stable. If a fuel control switch is moved to cutoff and the N2 is below idle while the aircraft is in flight, an in-flight start envelope appears in magenta. This display indicates the required airspeed for an in-flight start at various altitudes. The flight crew will ensure the aircraft is within these parameters before attempting an in-flight start. If the in-flight start envelope is displayed, but the airspeed and altitude are not sufficient for a windmill start of the engine, the magenta letters crossbleed are displayed above the N2. The crossbleed annunciation indicates the need to crossbleed pneumatic air from the operating engine to the starter of the failed engine. Therefore, when crossbleed is displayed, the procedure will tell the crew to start the engine similar to a ground start, using the engine starter. The lower EICAS screen displays the remaining engine indications. N2 and fuel flow are round dial gauges, each with a pointer and a boxed readout. The N2 display has a white normal RPM operating range and a red RPM limit line. If the N2 reaches the red line limit, both the pointer and boxed readout display in red. The fuel flow pointer and boxed readout only display in white.
Fuel flow displays in kilograms per hour times 1,000.
The N2 display has a fuel on command bug that indicates the minimum RPM at which the fuel control switch may be selected to run during the engine start.
The left side of the EICAS screen displays the oil-related parameters of oil pressure, oil temperature, and oil quantity. Normally, the pointers and boxed readouts are white. The oil pressure display has white vertical scales with a moving pointer for oil pressure on each engine. A pointer displays amber if the caution range is reached, or red if the low limit is reached. Just left of the EICAS are the left and right engine oil pressure lights. These lights illuminate when the oil pressure is at or below minimum. Note, these lights are helpful if EICAS is not operating during engine start. The oil temperature displays with white pointers and readouts. If a pointer reaches a caution range, both the pointer and readout display amber. If a pointer reaches the red line limit, both the pointer and readout display red. The oil quantity displays have white scales for the normal range. The bands at the bottom of the scales are there to provide crew awareness for low oil quantity. The last set of gauges of the secondary engine display are the engine vibration monitors. These monitors are primarily intended for engine condition monitoring, but can also be used to isolate engine anomalies and to take corrective action. Normally, the crew will reduce the engine RPM if high vibration is detected. Consult your flight manual for this situation. Also, remember to consult the cold weather operations section in the event of ice accumulations on the engine blades.
The vibration source is displayed either as fan, low pressure turbine, broadband. Broadband indicates an unknown source of vibration, in which case the average vibration is displayed. High N1 vibration may be accompanied by noticeable airframe vibration. This is not the case with N2 due to lower mass weight of this rotor.
The standby engine indicator serves as a backup indicator of the important engine parameters in case both EICAS computers or both EICAS CRTs become inoperative. Red numbers are painted on the SEI to display the limit values. These painted numbers are always displayed.
The indicator has a selector that allows the display to be turned on for test purposes, but is normally selected to the auto position to blank the indications. With the selector in auto, the standby engine indications automatically display when AC power is lost, or either CRT failed and status selected on the ground, EICAS has failed. This completes our description of engine indications. Now for the questions.